Lesson 6 is on understanding functions. And a function is a rule that defines a dependent relationship. So that's our first vocab word here. And a function creates exactly one output or result for each input. The diagram below shows the function add2. So the function or the rule is add2 in our input. So if we put 3 in, we would get out 5 because we have to add 2. That's the rule. So the input's what we put in, and the output is what we get out. So input are our x values, output are our y values. So there is only one possible output for each input. So this right here is important. Basically, in other words, what that means is our x values cannot repeat. So that is important today. That is one of the things you're going to look for. X values can't repeat. The y values can repeat all of they want. It's still a function, but if you have two of the same or multiple x values, then it is not a function. So the function add2 is expressed in words. It can also be written as the equation y equals x plus 2, represented in a table of values and shown as a graph. So the rule was plus 2, so we're taking our input of x and adding 2 to it, and then we get our output of y. So here, each coin of American currency is assigned one specific value in dollars. For example, the value of a penny is always 1 cent. In this function, an ordered pair relates the name of a coin and its value of dollars. So the first thing listed in a table like this is always the x, and the second thing is always the y. So our input is the coin, the output is the dollar value in this chart. Most mathematical functions include ordered pairs of numbers. For example, a 120-pound person burns about 65 calories per mile while walking. The table below shows how many calories the person would burn walking different numbers of miles. So our miles are our input, and that's our x, and our output is the calories burned, our y values. So the input is the number of miles walked. The rule is we're going to multiply by 65. So every mile you multiply by 65. So if you're going to walk 10 miles, you're going to multiply that by 65 to figure out how many calories you will burn. So our next story here is a basketball coach gives the starting players a game jersey. At the same time, he measures the players' heights. This relationship is a function. For each jersey number, he records only one player's height. If jersey number is the input and height is the output, then the relationship is a function. So as long as this is x, the jersey number is x, and the height is y, it is a function because there's not going to be multiples of the same jersey number. There's only going to be one of each. So x will never repeat in this situation. But if we flipped those and made the height the input and the jersey number the output, like modeled here in this diagram, then it would not be a function, because if you look, the input, which would be x, and the output here is y, this 68 is going to the number 10. It is also going to the number 18. So an x repeats here. So this is not a function. So always look at the x values. So this question, the reflection question, do the data in the table show a function? So that's the first question. So input and output. Inputs, do we have any repeats? Yes, we do. We have 3s and we have 5. So is this a function? No. And our reasoning is 3 and 5 repeat in the x values. If you switch the input and the output values, is it a function? So now they're saying that the output is really the input and the input's really the output. Well, we have -3, 2, 4, 5, and 6. Nothing repeats now for the x column. So yes, that is a function, and our explanation is x values don't repeat. So let's explore here. The table below shows the number of dog licenses issued in the town of Palmer over a 5-year period. On the blank graph to the right, label and number the axis, and then plot the ordered pairs. So I already have those labeled for you. The inputs, the years are our x values, so I put that on the x-axis up to 5. And then the number of dog licenses is our output, so that's on our y. And when I looked at those, we had to get from 75 to 150. So I started and I went by 15s so that we had enough space to get everything on. And then we have to plot. So 1 and then 75. And 2 is 100. I'm going to have to estimate there. 3 is 125. And so is 4. And then 5 is 150. Describe the relationship between the input and the output values. I'm going to say that each input has one output value because that is the case. Nothing repeats here. Oops. And I can also say that the input is the year and the output is the number of licenses. And the number 4, dogs age faster than humans do. Some people claim that the dog years are a function of human years, as shown in the table. On the blank graph to the right, label and number the axis, and then plot the ordered pairs. So again, our x's are the inputs, the human years, and the y is the dog years. So every year, so 1 is 7, 2 is 14, 3 is 21, 4 is 28, and 5 is 35. So describe the relationship between the input and the output values. We could say that each input is multiplied by 7. Number 6, the relationships on the previous page are shown as graphs. Which graph or graphs shows exactly one output for each input? Which set or sets of data represent a function? So the which show exactly one output for each input, that would be the dogs, because if you look up here, the 125 repeats. So the input of 3 is 125 and the input of 4 is also 125. So if we go back down here, which graph or graphs show exactly one output for each input? That's the dog ages. And then which set or sets of data represent a function? If I go back up here, do the x's repeat here? No, they do not, so that is a function. And then if I go back up here, the x's don't repeat there either, so that would be a function. So both are functions. And think about the function related to the dog licenses. Would there ever be one year that is assigned two different quantities? No, because each year, each year they are documenting the number of licenses issued for that particular year. So no, there's not going to be two numbers. So on year one, they only had 75. They can't have another number as well. They count how many are there for that particular year, and that is it. There's no other option. So that would be a no. And then look at your answers to problems 3 and 5 on the previous page. Can you represent either of the functions with an equation? So if you go back here, we kind of talked about it. This one, each value was multiplied by 7. So that one could be. This one up here, we're adding 25 and then it stops. We add nothing and then we add 25 again. So there's really not a function that we can write for that one. So going back here, yes, we can write a function. We can say y equals 7 times x for the dog because every year the dog is going to age 7 more years. So every time we're timesing by 7 if you wanted to know how old your dog really was. For questions 9 and 10 here, substitute values into the equations to complete the tables and then state whether the equation represents a function and explain. So here, x plus 2, we're going to take our x value of -2 and we're going to add 2. So -2 plus 2 would be 0. -1 plus 2 would be 1. 0 plus 2 is 2. 1 plus 2 is 3, and 2 plus 2 is 4. Is this a function? Yes. X values don't repeat. And then for the second one here, we're going to multiply by 4. So -2 times 4 would be -8. -1 times 4 is -4. 0 times 4 would be 0. 1 times 4 is 4. 2 times 4 is 8. And again, yes, this is a function because the x values don't repeat here either. Okay, I want to talk about one more thing up here. If you're given a graph and asked to find out if it's a function or not, you can do what's called the vertical line test. And that is simply, if we connect these dots, we're going to draw a vertical line through this graph. No matter where I draw that vertical line, I'm only going to cross that graph at one spot. So that passes the vertical line test. So if it passes through one point on the graph only, then it is a function. If it passes through 2 or more points, then it is not a function. And I will draw an example of that here in a second. Go over here a little bit. If I draw a graph that looks like that, and I do the vertical line test, if I draw it here, I'm going to pass through 3 different points. I'm going to pass through there, there, and there. So that is more than 1 point, so that is not a function. So that tells me that x value has multiple points. So the x value repeats there, and so it is not a function. So if